First of all, thank you very much for to all of you for joining Talk episode 3 of Talks by AI chapter at Sedin Technology. Today we're in for a treat. We have none other than Sudhakar Rayavaram with us, who's also a co-founder of Tarka Labs division at Sedin Technology. He is not just any other techie. He comes with about 20 plus years of experience with spread across multiple domains, including consulting, product development, AI, you name it, he has probably done it, but not just only skills. He's also an amazing mentor, and I should know that. Today, he's here to share a very interesting topic with us, which is build LLM powered apps using advanced RAG. With that being said, I'll hand over the talk over to you, Sudhakar. Just a quick note, guys, whatever questions you may have, please drop it in the chat box. We'll take it by end of the session. Over to you, Sudhakar.
Thanks, Sonia. Hello, everyone. I'm Sudhakar, and thanks for here. I hope that I'll make your next 1 hour as effective as possible. Everyone could be in a different levels of this whole LLM wave, and also how we can use it for building applications. I'll try my best to give. I'll start from a little bit basic, and then I'll go to advanced topics, so that way everyone will have something to take home, and you can reach me in LinkedIn and all for further discussions. So let me screen share and start so that I'll show multiple things and what is in plan. Are you able to see my screen shared? Yeah, okay, cool. Okay, so as Sonia was saying, yes, this is the topic. What are we going to do for the next 45 minutes or so, excluding question and answers time, let us deep dive. First is, yes, as I said, it's me, and this is the company website, tarkalabs.com. You can go and look at it, and we also are hiring, by the way. So I have to say that, so I'm saying that. And what is that we are going to do today is based on the experience that me and my team collected over building a RAG powered application called VIDURA. So basically, VIDURA is versatile intelligent document understanding and retrieval agent. What we did here is sometime, say 9 months or so before, that is when this whole ChatGPT, LLMs, all that were like a rage, right? Even now they are, but relatively. So that is very new, and everyone was very interested in what it can do, what it cannot do. And we started exploring a lot on those lines. So say, for example, we even created, I was, no, I basically, I made this Gen AI workshop. So there was this Gen AI workshop that I conducted some time back, where the code is open, anyone can go, just follow these instructions. You'll be able to get an app up and running using RAG. Any documents, any huge set of documents that you can throw at it, it will be able to talk to you. I mean, you can actually ask questions, and then it will be able to answer whatever doubts that you have in the document. It's basically like any other, like ChatGPT, what it is doing for the whole internet data, what this RAG powered application was doing. So why I'm saying that is, so RAG is not new, right? This, if you see, this was like last year, right? Almost an year, actually a year. So, but what I will try to cover here is RAG will not take you very far. And why? I'll also say what other things that are out there, active research happening. There are a lot of white papers written in this field, and we are also trying to implement some of those findings from the white papers into our product to make our product better. On those lines, I thought, okay, maybe I can share some of the other things, advanced features of RAG that we are trying to integrate to this product. And for example, this is the product. If you go to vidurabot.com, this is the landing page. You can go and you can see some demos. If you are interested, I also can let me know. I can give you the access for our demo site so that you can play around and all that. So the learnings is based on whatever this that we are able to do here. Before that, I know many of them might already know this, as I was telling that this is not new, this is like 1 year old. But just to keep it so that everyone can travel together, I'll give a very brief of what is this, right? Retrieval Augmented Generation, what we mean by Retrieval Augmented Generation and how is it connected to an LLM and all that. I'll briefly go over what is an LLM, but let us not get into the details, otherwise we will not be able to get to the GraphRAG and all that. So What is retrieval augmented generation? It's very simple. So it's basically all the three words, right? If we understand those three words, then we will know what RAG is, right? So retrieve, basically assume that you have a lot of documents. You have to retrieve the right fragments from it for the LLM to answer your correct questions. Say, for example, you have huge set of documents, hundreds, thousands of documents. A large language model cannot, no, you cannot dump the whole document's text and then ask a question. So you might have heard this term called prompt engineering, right? So how you prompt it is going to be very influential in what you get back, right? It's mostly here also it is garbage in and garbage out. That means if you are good in writing a prompt, be it image generation, be it video generation, be it anything, right? Be it even text responses that you get, a large language model, given that they are all just a next token predictors, right? Large language models are nothing but a next token predictor, to put it in a very simple fashion, but they're huge, right? The maths behind that is mind blowing, but at the end of the day, what it does is you give a statement, it will try to predict the next token or next word. Here I'm saying token because there is a little bit difference between the both. But it is just predicting what should come next based on whatever it knows from the context of your question, right? So on that lines, a retrieval, if the documents are many, we cannot dump everything into the prompt. So what can we do? We have to find the right pieces of information to send when we ask a question so that we'll be able to answer correctly. So that is the retrieval part. We have to retrieve the right pieces to give it to it, right? How we can do that, we'll come to that later, but this is what we should do, right? Find the right parts. Argument. So basically, this is what, after you found the right parts for your question, you have to put that in the prompt, right? Prompt will have different sections. Every prompt will have the context. That is where it says, hey, you are a very helpful chatbot assistant for this company, blah, blah. And then you will also have a conversation history of what was the past conversations so that the prompt, right, will have all the information. By the way, any LLM powered app or anything that you have used, right, be it ChatGPT or be it Bing, whatever it is, it inherently does not, the LLM inherently does not have a memory. It does not have the state. So every transaction you make with that is stateless. How can we manage or maintain that conversation? It is by having the conversation history like this inside the prompt. Can it go big? Yes. And there are multiple other techniques to handle that the moment that the conversation is going long, how to get, get that summarized without losing the context and all that. But yes, you will have conversation history and also you will put all this related fragments in. That way, your prompt is kind of an isolated piece that you can pass to an LLM via API. And then you will get the actual expected response back. So that is the argument part. The generate part is then it is, yeah, this is pretty much evident, right? So excuse me, you ask the LLM and the LLM will give you the response based on whatever you have given, context, conversation history, related fragments. And there are also multiple things that will come in the later point that I'll show. That is where the advanced part of RAG will come. But at a fundamental level, that is it. So if you're able to do this, there are multiple ways of implementing it. There'll be vector databases that is needed and all that. But if you're able to do this, you kind of have a base level RAG. And for this, as I said, if you just go to this, I'll share all these links after this. If you just run this workshop, you'll be able to pretty much do all this that I've shown so far. That's a very basic RAG that you'll get an idea, right? Okay, so one other important point that we should remember is, at least what we learned hard way with this whole building VIDURA is ingestion. So what I mean by ingestion here is chunking the documents into logical fragments is in itself a huge challenge. For example, think of a document which has images, which has text, which has not in an orderly fashion of paragraph, but 2-column layouts, 3-column layouts. Think of PDFs which has tables. Think of tables which are wrapping across multiple pages. So all this complicates finding the right fragments or chunks. If we are not able to chunk the documents correctly, the quality of output heavily degrades, right? We tried multiple things and usually they say, hey, just have a recursive text splitter with some overlapping and all that. That will not work for any real case scenarios, right? We went all the way till using Vision LLMs, Vision API endpoints with LLMs to actually understand the semantics of every page, how what is related to which, how to group the content text, and then summarize it and make it fragments or chunks for using it. So ingestion is also very critical. So we pretty much spent almost half the time in ingestion, right? Other than building the RAG pipeline, RAG, building the ingestion pipelines to get these fragments right was equally a harder task. And the moment you have fragments, it's very easy to convert to embeddings, right? So there are a lot of different models out there with the different levels of success rates with respect to domain and all that. But the moment you have a fragment, you can just pass it to any of those embedding models, and then it will give you vector embeddings, right? So I will not very detail into this whole vector database, what are vector embeddings, but to just make it easy for us to understand at a high level, think of vector database or this vector embeddings is an n-dimensional vector, right? Say, for example, if you take a graph, it has only 2 dimensions, right? X and Y. So any point just needs X value and a Y value to pin, right? 3-dimensional, you have X, Y, Z, right? If you can extrapolate that same for, say, 150 dimensions, 200 dimensions, right? Just think about the richness of that one point that you put in that. Yes, of course, we cannot imagine we are 3-dimensional beings, but the idea here is this. Every array here has so many dimensions, n dimensions. And this fragment, depending upon what it is talking about, what is the meaning of all those, it just finds a point in this n-dimensional space, right? And if the fragments are close by in some dimension, right, in any dimension, in some dimension, they'll cluster together in this n-dimensional space. That's the idea. So why that is helpful? That way you can find the related fragments when you wanted to pass it to the LLM to get your answers. They should be grouped somehow, right? More the dimensions, more richer the clustering will be, so that you can get better answers. That is the idea. So vector databases now like Quadrant, you have a lot of this, databases, and then you just can store them. And vector databases is pretty straightforward, right? The moment they are just comma separated numbers, hexadecimal numbers, storing them, retrieving them, attaching some metadata to them, it's very straightforward, right? So that is what is happening here in ingestion. We'll convert this, thousands and thousands of fragments to embeddings, store the embeddings in vector database, so that we can do search in vector database to find the most closely related cluster that would have all the information to give us answer for our question, right? So this is all with respect to the ingestion. Yeah, so this is what I was talking about, right? The GenAI workshop RAG example. This is one example that you can see. There are lots of code out there, but this is just one example that you can use. Okay, so in the whole topic, right, my presentation topic, what was there is some of these words like ERAGent and GraphRAG, and also we have DRAGIN and all that. What are they? They're basically some of the popular, I think they're popular based on what I was searching, or looking around all the things that are happening in this RAG space, all right? So these are all white papers. If you see here, this basically archive, right? This archive pages, if you click on them, you'll be able to actually, maybe I can show one, wait. I can actually, show the white papers that are there. That will give us a lot of information, a lot of ideas at least, right? For example, for VIDURA, we were hitting roadblocks left, right, and center, right? So the moment we started taking it to one of our, some of our potential customers, then we are hitting roadblocks, right? Saying that, hey, yeah, I mean, technically they're supposed to work well, but what happens on this scenario? The kind of data that we saw, the real data always is going to make it very interesting, right? So this is one of that white paper, right? It is from Sydney, right? The ERAGent. And this white papers gave us some ideas that we can implement. Some of them we have already implemented. Some of them we have not. We are still trying out and see whether it is logical, because there are a lot of scenarios, a lot of situations or the domain specific things that make it effective or not effective. So I just wanted to give, share with you some of the 3 different papers from which we felt, hey, there is a lot of potential for VIDURA to evolve, and sharing it so that I'm also hoping that other people who are already doing this journey, traveling in this to build how to use LLMs effectively and all, I'll be happy to connect and see what is working for you folks, what is not working and all that. But the idea here is this: at a high level, share what we are finding in building our product and then see if we can go, because this is highly in active research, right? Pretty much every week, I'm seeing something or other coming as an addition or an improvement to what was working. And all these white papers are very well written because they have all the information about how they are testing it, what is the data set they're using to test, how good are the results. And it is also, from some of the papers you can compare because they give a lot more information about, so that you can run it in your local. But some papers, it is not very clear. You cannot run it or you cannot replicate it to an extent. But that's okay. At least, it will help us to think through what other things that we can try to. Okay, so in ERAGent, so basically what ERAGent is saying is, see, you enhancing the retrieval augmented language models with improved accuracy, efficiency, personalization, lot of words. But don't worry, I'll try to break it down and give a bird's eye view of where this whole advanced RAG is going. And the last one, the GraphRAG, is very interesting. So maybe I'll also get there and say how different people, different researchers, different PhD researchers are thinking in different angles to make this efficient, right? This whole RAG approach efficient. So what does ERAGent say? So ERAGent basically at a very high level say this, right? It is a combination of multiple ideas put together in the RAG, Retrieval Augmented Generation approach that I showed you, right? All it does is you have to start from here. So enhanced question rewriter, right? Sometimes whatever the question that the user is asking may not be able to find the right information with vector search. Multiple reasons. It could be multiple reasons, right? One example here is who sings backing vocals to piano on one of these nights song, right? I mean, users can type in anyway. They might use some colloquial words. They might use some other abbreviations, short forms, whatever it is, right? So ERAGent paper suggests that hey, it is a good idea to rewrite the question with the context, of course, right? The context could come from anywhere. But if you are able to rewrite the question using an LLM so that it can expand on it and also make it lot more, the hit rate of getting the right vector space a lot more higher. So that is what the first step is. They're going to rewrite the question. But so usually whatever I showed, right, the basic RAG, it is just one shot, right? So it does this retrieval, it puts that into your prompt, and then it just gets the answer and returns it, right? All these models and some of the more other different ideas, they go loop, meaning they go back to LLMs, they call LLMs multiple times at different places, and they break down this one RAG flow into multiple sub pieces so that they can go and get LLM help at a small subtask level. From what we have seen and from what the research shows, breaking the bigger chunk of work into smaller pieces and augmenting smaller pieces with LLM with a lesser context is much more valuable and effective. But the downside is now all the responses is going to be a lot slower, right? Because LLMs, when you hit an LLM, it is going to be slow, right? It is going to go over the network, or even if you're running an GPU, if you're running a model locally, LLMs will take time, right? So that automatically means that when you do this multi-loop, any of this approaches implemented, your responses will be slow, but the quality of the responses will increase. It's always a trade-off, right, between the quality and versus the time. That same applies here also. Okay, coming back to this, you have this enhanced question rewriter. So you rewrite the question, and the next step is find out what are all the different questions this one question is, right? So they are using LLM again to break that down one question to multiple questions. And after breaking down those questions, there is this retrieval trigger component. This component will try to find out, hey, do I already have information? It could be based on my model, whether the model knows about this or whether the information that it has been fine-tuned with or whatever it is knowing about it or not. All right. So that is what here it is trying to say. Q1 already has M1, M2, M3. Q2 has M4, M5, M6. Those are some of the chunks of answers that it already can map to these questions. But Q3, it found out that, hey, there is nothing it has related to one of these nights. It could be a vector search. It could be even looking at what the LLM kind of knows, right? And then only for the questions that it feels that it does not have any information, it is going to make a retrieval to the vector, right? Or it could be BM-based search also, right? It could be text-based search in its knowledge repository to find out only those chunks, even external, even E2, E3 for this question. So now the moment this one question is broken down to multiple questions, it is able to detail out and find out more logical chunks for each of the questions. The moment it has the chunks, then it is kind of easier, right? They are doing this some optimization here because of the context length, right? Sometimes the context length could be very small for some of the models. Say if you're using a 8 billion model or whatever it is, right? So that is why they have a filter, but it is optional. We can also run all of this without a knowledge filter. And they're just filtering all these chunks so that the most logical ones are taken. This is also done by LLM again. So we are asking LLM to say, hey, tell me out of all these chunks, right? We also can batch it. VIDURA actually does it. It can batch and then give chunks and find out what are the most logical chunks for this. And then it will take only those chunks. And that is used in the personalized LLM reader. This is also one other interesting idea. So if you see this, the personalization part at the end right here, it means that they wanted to personalize the answers by building a user profile. So if you see this experiential learner, it is building a user profile as what user likes, dislikes, and all that. So that is used to personalize the result of what you will get. I'll show an example why on which places this will be very useful. For example, one example here is basically a enhanced question rewriter. This is a good example to say how a rewriting will help. So this is basically a doctor's note. Assume someone in the medical space is writing. There are a lot of this short forms, right? SOB, SPO2, COPD. For them, it is their domain, right? This is how they speak. This is how they interact. But for an LLM to be a lot more valuable, it has to be expanded. So the same question when rewritten with all these expanded keywords, there is a better chance of this application or this agent to answer better. Now, why? Because most of the documents will not talk about PR and HCTZ, right? Because it will expand on those words. The words are right, hydrochlorothiazine. It's not HCTZN, but it's basically hydrochlorothiazine. So that way, it will be able to have a better hit rate, and then you'll be able to get better responses back. This is with one example of rewriting question. And the other example is this one. So user preferences, right? Say, for example, if someone is asking for a food plan, food program, right? The personalized information like, hey, Indians not eat beef, environmentalist, he's a late sleeper, and no milk allergy, whatever it is. That information will automatically be included in the questions that he is not typing it, but the user profile built and that is passed in every question asked to the LLM will automatically make it very effective for customized for his needs. I mean, this in isolation also you can do it. Even you can do it even in plain drag, right? Just that this paper also included multiple things together, and then it is just packaging it as one. But as I said, you can have even some parts of this also implemented, and we are also doing that. We are doing implementing on whatever that is needed as pieces and bits. That is with ERAGent, right? This is one paper. And there's a very detailed explanation of all this in this paper. So I think whoever is interested, please feel free to go in details and discuss. The other one, the next one is DRAGIN. So DRAGIN is one other paper, white paper, like this is the dynamic retrieval augmented generation based on the information needs of the large language model. What it does is actually very interesting. I mean, this is what I feel that a lot more impressive. Well, yeah, you don't need to compare. Everything has its advantages, but this I'll explain you why I'm excited about this. So let us take this example, right? So this is what even the paper I tried to explain what DRAGIN fundamentally is trying to say that will help with better RAG, right? So here, if you see this input, right, there is a question already asked. Say the question is, please give me a brief introduction to Einstein. Very straightforward, simple question, right? And LLM is generating, right? So it is not one shot. It is generating all these words. Einstein was born in German Empire and moved to Switzerland in 1985. It generated that. As I said, LLMs are next token creators, right? Next token predictors, and it generates the next token. So every token is getting generated based on the past tokens. So, but the thing is, say for example, the LLM is creating word by word or token by token, and then it went all the way to he secured a job at the, and then this University of Zurich it created, but it is highlighted in red. What is happening here is this whole DRAGIN paper, what it is suggesting is it has two pieces to it. One is RIND, that they call it as RIND, real-time information need detection, and the other one is QFS, query formulation based on self-attention. What are they? So real-time information need detection is awesome. It's very cool idea. Why? Because what these guys are trying to do is when the next token is generated, you always check what is the confidence of the LLM in generating this next token. Okay, and they have a formula to calculate the confidence. If you see this, S-RIND, basically the score. This is the score. This is the formula. Maybe we don't need to go into the details of these formulas, but I'll give you an overview and I'll tell what it is, right? So every step, they are calculating the entropy, they're calculating the max attention value, and they're also using the stop word indicator. And they are using some formula to come up with a number. If this number is greater, they say greater than a theta. Theta could be any value, and you can tweak it to see what is the best effective value and all that. But if it is greater than that threshold, what it means is, hey, the next word, the university word that it created, LLM is not very confident of that word. It is predicting, of course, it is predicting every word. But when it comes to this word prediction, it is not very sure, saying that, okay, I'm maybe it's university, but this is what I can give best for you. So what this formula that they are doing is they're using this entropy and attention value and also stopwords. Stopwords is basically what it does is you don't need to worry about stopwords, right? A, at, the, is, when. That is basically not going to change the meaning, right? That is why those words are just marked as zero, so that the value is always zero. That will not trigger this whole information QFS. What QFS does is basically real-time information need detection. RIND will trigger saying that, hey, now the LLM is not confident of next token. What QFS does is when that trigger happens, it will go and get more information. See, query formulation based on self-attention. So what it does is, hey, it will stop the generation process and it will go saying that, hey, there is less confidence. Let us try to find out more information from the internet, from vector database, whatever the sources it is, by passing the X tokens, the past X tokens here. Say, for example, maybe it might take the last 20 words or 20 tokens or whatever that is. And there is a logic to it. And that is also well explained in the paper. And then it will go and fetch for external information, get the information back, and then use that in the prompt or augment that so that now the next token will be predicted properly or with much more confidence. That is why if you see here, he secured a job at then it changed to Swiss Patent Office instead of University of Zurich. Why? Because it was able to give a pause and then it is able to go back and get more information on demand and then generate the next token with more confidence. This is very cool. Why? Because a typical RAG is one flow, right? So you get a question, you just do a vector search or whatever search, you get one set of chunks, and then you just put the chunk and expect the whole answer to be generated. But here now, this is much more nuanced, right? Whenever it detects that it is not confident, it is fetching the information on demand. So this obviously will make it very, very effective, very, very good quality results. But again, the more you look up, the more slow it is going to be, right? So because every time you are going to pass, you are going to make an search, you are going to get that condense, send it in the context and restart. So those things are all going to make it slow. But for domains or situations where the information to be true, to be correct, is a lot more critical than just it being slow by a second, then we should definitely see and implement things like this. That is DRAGIN. Yeah, I just don't want to stop for questions because it might take more time, but please note down and we can actually look at those questions and discuss, because I also plan to have some more discussions after this whole flow is done. That way we'll have some 10-15 minutes at the end to just go over some of the questions, yeah, and then we'll discuss them. Okay, so far what we have seen is all in the text space, right? You have a lot of text chunks. You take that text chunks and then you will see how you break it down, and then you store it, and then you will take it out and then you use it, right? What is very exciting in the space outside of that, only seeing in vectors as text and words and sentences, is building a relationship between them, right? The moment we think of a relational way of building things, yes, of course, relation database comes to mind, but a graph database, right, where you have a highly complex nodes and relationships and how they are connected and all that can be built. That is what Microsoft, especially Microsoft, researchers in Microsoft are spending a lot of time on this GraphRAG. They have very nice tutorials. So it's just, half a day, you'll be able to get a GraphRAG up and running. I'll show some demos that I'm running in my local. And then, they have given very nice pipelines setup where you can put the content and you can run those pipelines, you can configure those pipelines and get all the graph built, right? This whole GraphDB, be it Neo4j or whatever it is, built and then use that for inferences. So Microsoft is definitely, from what I've seen, Neo4j to an extent, and Microsoft both are actively doing development and sharing it in open source, so open sourcing it and sharing it to the whole world. So this is definitely an active space. So yeah, a quick time check. I have 10, 15 minutes. I think I'll be able to talk about it and also give you a demo. We'll see. Okay, so this is also a paper. So there is this GraphRAG paper, and you can use that, to go in detail. But I'll give a brief of what the idea, why it is very interesting, so that you can go deeper when you, take the paper and read it. Okay, so GraphRAG, what does it do? Why is it different? The same things, right? You have documents and you break them down to fragments. This is not changing. You still need to have a good ingestion pipeline. You should still need to have how to find the right fragments, breaking it down. All that is not changing. But what changes is the moment you have smaller chunks, right, which are logical, which are well formed, or which are logically broken and all that as fragments, you can basically use a graph. You are basically building a graph. What you're doing is you are extracting the entities, relationships, claims from each and every fragment in isolation. So you take a fragment, you see all the different nouns, verbs, basically entities, right? Different entities. And then you see different relationship between the entities. You need an LLM or something powerful, some NLP or something that will understand these, extract these things, right? You can use multiple things, but they are using a small model, medium-sized model to do all this. And then you're basically building a graph. So you keep on building this graph, and then you do the more, yeah. So basically, you keep on doing this, your graph is going to get bigger and bigger, right? You're taking every chunk, and then you're finding the entities. Obviously, if the entity is already present, you will just use that entity. If a new entity is found, then you'll create new entity, and then you will build a huge graph. So this is basically a graph that you've built. After building this graph, okay, what happens is you do the community detection. So there are algorithms out there for doing this quick community detection. What community detection does is you have a graph, you are trying to find the communities inside that or related information inside that, right? Hey, these nodes are highly cohesive or related when compared to other nodes. It could be because of how tightly the relations are between them. It could be because of how many times it is repeated, and it could be multiple logics right there. But the idea is you find those communities, and this is not one level. It can go multiple levels. For example, you have this big community that will have sub-communities. Maybe these 3 nodes are connected, and maybe these 5 nodes are connected. So you will have multiple sub-communities also identified. So the paper says that you can go n levels. Different levels will give you a lot more contextual or a lot more richer information about the relationship between this information, right? This whole documents. So you build this communities. Once you build the communities, you basically create community reports. So what the GraphRAG paper is suggesting is now you have identified the communities and you have identified the sub-communities and everything. We need to work in a text space, right? LLMs can work only with text. They understand only tokens, right? We cannot just throw this whole graph database into it to make inferences. We cannot, right? So what they are suggesting is identify the small communities or every community at every level. Ask LLM by taking all the text and ask it to create a summary. So take that summary and store those summary information. That summary, if done right, you will be able to read that summary. I can show some of the examples at the end. Read a summary and get an idea of, oh, okay, this community is talking about this, and that's nicely summarized with all the information. So they are creating the summary, and they're also creating the table information. So they are also identifying the entities and relationships, and they're also recording that as text, right? And they're all interconnected also in tables and summary community reports. And once after that is done, they are going to create embeddings. So the moment it is in text space, you can do the typical RAG, right? To take the text, convert that to embeddings, store that embeddings. Now you are again in the RAG space, where the moment you have embeddings, you can ask with your question, you can rewrite even the question. So you can do multiple things, right? Now you can mix and match multiple ideas. You can rewrite the question, make it more effective, and look in the graph space to get better context, and then use those, some community reports, or even use the entities relationship information and frame your prompt and then you send it and get the results. So at a very high level, GraphRAG is what it is doing this, right? There are two places. There is indexing time and there is query time. So indexing time happens only once, right? When you're indexing, when you're dumping a document into it. Query time is when you actually make a call, the query time happens. So this is the flow that it is trying to explain in the paper, saying that, hey, you have documents, you create text chunks, and then you find instances, elements, right? All this different entities, relationships, and all that, and then you create summaries, right? And then you find out the community, do the community detection, find the graph communities, and create community summaries, and create also community answers when the actual query, when someone asks a question, and also create global answer. I'll tell you what this local and global answer is. They have two ways of asking a question. You can go at a global scale. That is the one level, that is top level community summary will be used to answer that question, versus the local, where you can go much deeper into one graph sub network and then get much detailed information. So those are the two different ways. Before, let me quickly show you the demo also. I have 5 minutes. Okay, I have 20 minutes. Good. Okay. Before I go into that, okay. So this is the, as I was telling, right, this whole Microsoft GraphRAG. So if you go to github.com, Microsoft GraphRAG, this is the repo. They open sourced it, and it's very nice. They have a lot of good documentation. For example, this one, right? They just give you the whole information about how to run a GraphRAG, how to index them, right? And they have exposed. They basically, put it as a package, Python package, and then you can just install them and you can run the indexer. That is where actually it creates the graph. They used a book, Christmas Carol by Charles Dickens. That is the book they use. And then they're doing all this, and they are also able to ask questions. So, for example, here you can ask actually a question at local level or at global level, as I was telling you. So, let me also quickly show you the code. Okay, they are using LansDB, by the way. And that is fine. I think we can use any database, but they're using LansDB, and then that stores the files in Parquet file format. And that's why you have a lot of Parquet files. Let me show you the input first. So the input is one book that they've taken. This is a huge document, right? What it has around 4,000 lines, and it's also an open book ebook. So it's Project Gutenberg book. So yeah. So this is Christmas Carol by Charles Dickens, and what they did is they are basically running this through this whole pipeline that I showed you, right? So this one, yeah. They're chunking it, they're creating instances, the whole community detection, all that they're doing. After that, all it is done, we create this, basically this code creates all this community reports. And if you see, there is a report for every community level. This is what the summary, and this is the full content. All that it's basically curated. In a way, they are putting all this book information into a graph, extracting the logically connected things out of it, and then they are storing all this in different Parquet files, right? Nodes, entities, relationships, all the final text units. These are basically the fragments, by the way. Text units, they call fragments, they call it as text unit. And all this is present. They also create a stats.json file, how much time it would take to run and all that. So once you have this, then it's kind of, you also need to give an API key so that it can connect to some LLM. I'm using OpenAI LLM here. That is there in settings. You can just give what to use. And after that, you can just basically start asking questions to it. For example, basically here, one of the example that I have is this, right? So GraphRAG query, and then you're basically calling that by saying do a global, and then the query is who's Scrooge. Scrooge basically the main character in that book. And then if you notice, it definitely is slow. For example, I can just run it and show you. If we just run it now, it is slow. When compared to VIDURA or whatever that we have built, it is slow. Why? Because of the very simple fact that it is doing with multi-loop. It is not doing one shot and getting you the answers, but it is going back. And then it is actually looking at multiple levels across multiple graph nodes. Even if I say global, it is also doing that. So it is actually using OpenAI chat, and then it is right now it is actually asking frequency penalty. Okay, maybe it is running. I can show this. Yeah, global search response. Oh, yeah, I think it just got by global level. If you look at the local does a lot more steps. So local search response here. Yeah, so local search response. Okay, it's not printing it here. I'm not running it in verbose mode. But yes, the idea is this at a higher level where you can actually ask a question and test it and then see how it is performing. And this library, nicely abstracts it so that there is you can test it with any content. And they also have set this pipelines. Let me show you that we can actually change. If you go to settings YAML. Oh, it's in the other repo. Okay, this is actually the repo, the GraphRAG repo. The whole source code is there. So here, if you see, you have indexer. This is the one which indexes all of it. And if you see the configuration, they are having a configuration. They're even having a prompts. What are all the different steps that it needs to do, and then we can also customize this, and also you can create pipeline configurations. So there is a lot of this settings that we can do and changes, and when we can tweak it to our need. And also you have all the prompts here. Say, for example, okay, claim extraction. For extracting a claim, this is the prompt they're using. And to create a community report, this is the prompt they're using. Right? We can tweak this to our domain needs and then run this pipeline. And then we'll be able to tweak, control how the community reports are created, for example. Right? So yeah, this is all open source, by the way. Yeah, so this is the GraphRAG, the source code, and this is what we just included the GraphRAG as a package, and then we are putting our inputs, and then we are running it. And once once we get there here to run it, and then we can just expose it as an API and play around. Is what is the current state. That and there are some places that we are still exploring. I'm also exploring as how else what are the things that we can tweak. But at a high level, this looks promising because of the very simple fact that the whole fundamental idea that this is actually relying on the interconnectedness of the information other than looking it as a text in one dimension, right? So that is why this looks exciting, but also GraphRags are definitely slow to give responses to our questions and all. Yeah, that is with GraphRAG. I don't have much of the other contents that I need to cover, but if you guys have any questions, the last 14 minutes, right? So 5 o'clock it is wrapping. If you have any questions, we can discuss, and whatever that I know, I can share. Things that I don't know, maybe we can connect later and all that. But yeah, thank you.
So, Sudhakar, there are two questions, I believe, in Q&A and one in chat as well. We can begin with
Okay.
them.
Okay. Should I see Q&A first or it's loading? Okay. Microsoft GraphRAG, Karthi. Okay, Karthi is saying Microsoft GraphRAG has some pain. When I was using it and executing the notebooks on local search, they shared those notebooks work well with version 0.3x. Current version is 0.5. Which version are you using? Karthi, I'm using the latest version. I think the latest version is no, not 0.5x. It's much after that. Let us check. No, this is what the version that I'm using. They're already in 1.01. So this is what I'm using. 1.0.1. I don't know if Karthi is already there. Yeah, but yeah, that is what I'm using for the GraphRAG. Manjunath, what is the best mechanism to handle user prompt queries where data is in the different data sets in RDBMS and data will be changing dynamically in RDBMS using RAG template library or using ontology, etc., and responding to user queries without any higher selection? Okay. Hey, that's a good question, Manjunath. So when we talk about this whole retrieval augmented generation, we always talk about documents, right? Hey, you already have the documents. It is not live data. So what we did as an experiment is for that live data, we are also integrating that to VIDURA. Some parts of it is already integrated. What we built is this Sita. So what the Sita does is it's basically an API integrator. It connects to API. Like how some of the things that I was showing you, right? Like you need the data on demand, you fetch it when you are augmenting it, right? Instead of looking at a vector database, what we are doing here is function calling. So there is a concept called function calling where you can actually make an LLM to build the function to be called Python function, and then we just execute that function with parameters and all that. By using that, if an LLM is able to build you the right function with the right parameters, you just execute that function that you already implemented. That will make an API call and get you the right data. The moment you get the data, transpose it, convert it to text or whatever format and put it in your prompt, right? So there is a way. And VIDURA for one of our clients, even for this EM360, right? The second version, the next version, what we're doing is basically that. That is why this is all talking about APIs, right? It is not just integrating documents, but we can also integrate APIs. We have mixed success in this because sometimes, right, APIs needs to be called multiple times. And if it is a GraphQL based API, then of course you have much more granularity, right? If it is REST based APIs, the API definition is going to restrict you, and then there might be much more time. It is not very generic. It's going to be a very implementation specific for client per client, is what we noticed. But yes, it is possible. No, as long as you can augment with the live data using API function calling, you can do it. And we are also to an extent doing it successfully. Okay, I'm just looking at the chat window. Srihari, why we need RAG? Why it important than NLP spacey in extraction? Okay, I think I don't know when it was put. It was put in 4.11. So I don't know whether after me explaining the retrieval augmented generation, if it is not clear or clear, but I can repeat it if no, Srihari is there. But the idea is this, right? So your NLP will only identify, right? You will be able to understand the meaning or semantics of a text, right? But RAG is needed only if you have huge amount of data and you cannot put all that in your prompt, right? Your LLMs does not, it is at a much bigger abstraction, right? They do not work at an textual understanding alone. It's beyond that. It's textual understanding, reasoning, and also responding. So I think it is a much higher abstract level is what I feel. Any other questions? Sognia, should we just open it for the forum to discuss, or what is the process?
It is open. Anybody who has questions, please go ahead.
Hey, hi, Sudhakar. I have one question. So let's say if you are implementing a chat over a RAG, right? How to deal with limited context length, right? So I've read about techniques like summarization and other things. What is your experience if I'm building a chat over a RAG, right? With limited context length.
Yeah. So VIDURA bot is basically a chat over a RAG only. So if you go to this, right, it's basically a chat over a RAG. Let me do it. Okay. But the fundamental question, the problem lies, right? For example, documents could be huge. So only if you are able to include the right fragments into your prompt, you will not overflow your context length. You cannot have huge, right? So since because of only that restriction, the whole idea of RAG exists. I'm very sure in a year or 2 or 3 years, whatever it is, right? This whole context length of you cannot pass more than 8,000 tokens or whatever count of tokens to your LLM and your asking question will go away. If that goes away, then you don't need RAG. You can pretty much dump all the documents and say, hey, remember this? When I ask, answer me the questions, right? Even it could be at a state where you dump the documents, the fine tuning is going to be so cheaper and so faster that you don't need RAG. You just fine tune your LLM model with all the data, then you don't need to augment your retrieval at all. Did I answer that question or I'm missing the point?
Right. Yeah. So when the future where the models can take, let's say, millions of tokens, this problem will go away. But what is today's techniques of dealing with it?
That's what. So we don't pass all the documents, we pass only related fragments. Like here, what I'm trying to screen share. Your documents are broken down to smaller chunks, right? Don't send all the chunks. Send only subset of the chunks. How will you pick the subset? That is where vector databases embeddings come.
Sure.
Okay.
Anybody else has any questions? We still have some more minutes.
Any experience on Arvind again here? So any experience for textual documentation, it is fine. Let's say if you are using the same thing for legacy code understanding, right? Any experience of a GraphRAG for legacy code versus the normal just chunking and other things?
Yeah. So so with respect to the whole code creation, understanding of the code, yes, they are related. But for example, we are using Claude, right? The Claude is actually very good because it's already tuned with all this code, Flutter code, and all that. We're able to generate a lot of code. But yes, our RAG for code generation, we have not seen at a code level. But GraphRAG is an ideal candidate. Why? Say because, for example, you take the code and you create, you basically build this whole code into a graph with all the interconnections, right? Then you pretty much will be able to use the same GraphRAG techniques to find the summaries and find the communities, right? Communities could be all the methods calling the other methods, or it could be different layers, and then you'll be able to infer better. But we personally, we have not gone into the code generation space yet. Maybe if some customer says that, hey, can you use VIDURA for this? Then we'll start jumping in and then trying things around it. But so far, what we are doing is we are just using the tools for our code efficiency purposes. We are using Cursor, and obviously now they made GitHub Copilot free, right? So then GitHub Copilot, today they made it, I guess. So it's free, right, for everyone, right? So we are just using those things. And yes, with the minimal contextual tasks, right, writing unit test cases and all, it is working well. But if the context goes beyond or bigger, then they falter, right? I think that is the current state. But yes, we have not got into implementing GraphRAG for code yet.
Yeah, thanks.
Yeah.
Sudhakar, Karthi has one more question in Q&A.
Wait, am I seeing it? It'll be on the top. Okay. LLM deterministic. Yeah, I think we also have those problems, right? This determinism problems is always there. So it's going to be very hard. I mean, you set the temperature to 0. You said that, hey, don't hallucinate. You set however prompting you want. Yes, there is always a chance that, I mean, by default, LLMs are non-deterministic, right? They are neural networks built in a way they are predicting missions, right? Prediction or probabilistic nature missions are always non-deterministic. I think fundamentally that is what is going to happen. But we can do some check balances or have some rail guards or have some correction mechanisms after something comes out of the LLM, right? I think that is how I see it. But making it deterministic, there is already a lot of effort going there. But I feel fundamentally, we cannot build a deterministic system out of LLM just with using an LLM. We should build a lot of things around it, to safeguard us from its non-determinism. But I mean, who knows? Maybe the whole next generation of LLMs could be a lot more smarter. We never guessed that LLMs will come this faster here. So yeah, maybe Karthi, in future, they might be a lot more deterministic than us. We'll see. But right now, yes, they're not that good. Determinism.
Sudhakar, Arvind, again here, so just one question. So, the places where RAG I feel fails is when we ask it to probably ask for a trend. For example, summarize something, right? So I can only
Yeah,
fetch relevant documents. Let's say if I'm ingesting all my Jira data and then ask what
correct,
was the bug count for the last week, it will certainly fail, right?
correct,
So, what's your
correct.
thought on this, on approaching problems like this? Is fine tuning the only way, or what?
No. Fine tuning will not help actually. So the GraphRAG paper was talking a very nice idea for that. So the moment you get to this graph, right, Karthi, now you have information not just at textual level. You can do counting at this level because now you have a graph, and what you're doing, you're basically running some tools over it to create community reports, summaries, right? When you're creating summaries, you can also build your tooling in such a way that you do the count from the graph, right? So it's very easy because now it's already in some structured fashion. It is not like text all over, right? And it chunks all over. The moment you have a graph built over it, then you can actually do the counting, stats, metrics, and all that, as long as your graph is built effectively. If it is able to identify the entities correctly and all that, then you have a better chance at doing the stats in a graph RAG than with a normal RAG. We have not got a chance to do this. What we did is when we had that requirement is we took a function calling approach. For example, let me quickly show you what we did. So in Tarka Labs, right? So we wanted, so this warehouse company, I mean, one of our customers works highly with warehouse management systems. So they needed this whole, LLM powered chatbot to create reports and all this. So what we did here, if you see, we are able to actually ask questions and then you're able to create this charts. And here the data should be perfect, right? We cannot say, hey, this might be 95% right with your data because business is going to make decisions with this information. So it cannot be wrong. It has to be perfect, right? So what we did here is function calling approach because we cannot use this whole, giving it to LLM to decide. So we call the appropriate functions. We'll get the data by hitting the actual SQL databases. use that information, and then we have multiple other tools, right? The moment you get the information, and then we can just, we are using here one of these libraries, the charting libraries, and then we're just showing that.
Yeah,
but yes,
that works.
that is
Just one, yeah. Just one final question with related to storing of these data. So let's say again, I'm getting Confluence data, for example, where the information can keep getting updated. So I have a version of a document, but there will be new versions of the document and this thing, right? My accuracy most probably will be based on the recent documents. If my vector DB has all of these things, right? How do I change the prompt or make sure that I am getting the most recent data which is more accurate?
No, you are.
Or how do you maintain versions of the same information? Yeah.
No, this is the ingestion problem, right? Again, you're saying I'm going to cut, my ingestion is just going to dump for all the new documents that is going to come, right? But it can be smart. It can remove the old version as long as you have a metadata information. Because in vector database, when you're dumping a vector, you can attach metadata to it, right? It can be even created by when it was created, even the actual text. That is how even when you do a vector search, you get back the actual text, not because you cannot. A vector embedding cannot be converted back to text, by the way. It's one way, right? They attach the actual text so that they'll use that metadata information to pass it to the prompting. So that way, if you have the document, some identifier of the document, it's very easy for you to find that existing document, delete it, and put a new document and create an embedding for that, right? So this is basically a problem outside of LLM, this whole RAG approach. It's in the ingestion. How you control this ingestion, how we are going to get data information into it. That is how we are dealing with it now.
Right, thanks.
I think we are out of time already, but we will send you guys a feedback form that where you can send out your question, and Sudhakar should be available on his LinkedIn also. If anybody has any question, feel free to reach out. You can also send the questions on the feedback form, which will be sent out to you right after this webinar. I hope you had some takeaway to take back. Thank you so much, Sudhakar, for being here and giving us some insights.
Sure. Thanks everyone for listening to me for an hour.
It was a wonderful session.
Thank you, Sudhakar.
Thank you.
Thank you. Bye-bye.